Hi, my name is Connor. I'm a member of the Albany Senior Academic Committee, and I'm here to do a quick tutorial about beats and tuning forks. It's a level 3 standard, level 3 physics, and the tuning fork portion of this tutorial was actually the excellence question in our internal this year, so hopefully it'll be of some help. First off, I'm sure you all already know that sound travels as a wave, and that when you get two waves colliding, they interfere with one another, and they'll either produce a louder sound, a diminished sound, or a completely different sound depending on the constructive or deconstructive nature of the sound waves interfering. Well, a beat is a very particular type of interference. A beat is heard as a distinct fluctuation in sound which occurs when two waves of very similar amplitude and frequency, very similar but not the same, interfere with one another. And this is the basic principle by which people who tune instruments can use a tuning fork to tune an instrument. So right behind me I've got a piano, and each key will play with a different frequency. An actual piano would be because of the strings, and this one is electronic. But in either case, each key has its own individual frequency, and a tuning fork is made to be struck at an individual frequency as well. The thing is, one of the frequencies will ideally match up to one of the keys on the piano. So if I say have a tuning fork for middle C, and I play middle C and strike the tuning fork at the same time, if I hear a beat, I know that there's a very slight difference in the frequency, and depending on the number of beats, I can know how far off the frequency of the key is from the tuning fork, with again the tuning fork being set to the ideal frequency. From this, it's a simple process of elimination by adjusting the frequency produced by the piano until there's no beat heard, at which stage you know that the key and the tuning fork have the exact same frequency and amplitude. Therefore, the piano is perfectly tuned. Once again, an important part of this assessment is that you note that as the greater the difference in frequency between the tuning fork and the piano key is, you'll hear more or less beats. This helps a person tuning an instrument know whether they need to adjust the frequency of the key by a large or small amount. And as to which direction you adjust it, you simply choose one. If the beats diminish, you know you've chosen the right direction. If, however, say you've decreased the frequency and the beats are getting more noticeable, then you're going to have to increase the frequency to balance that out. Thank you.